Our second presenter is Simona, and so she's going to talk to us about visualization of origin, destination, traffic flow using vehicle trajectory data. So Simona has more than 15 years of experience in the development and evaluation of advanced, innovative information technology applications for transportation. Currently, she's a data scientist in the traffic engineering division of the VDOT. Her main focus is using advances in data science and computing and incorporating new data science, new data sources to deliver information that is used to improve decision making. So with that, Simona.
Thank you, Pat. Good afternoon. So my name is Simona Babiceanu. I'm with the Virginia Department of Transportation, and today I'll be talking to you about visualizing origin-destination traffic flows using vehicle trajectory data. The motivation for the study was to study the impact of converting the I-66 inside the Beltway lanes in Northern Virginia from an HOV2 regime to what VDOT calls express regime, whereby in the current express regime, HOV vehicles are still allowed to travel for free during the peak period in the peak time, but nowadays also single occupancy vehicles are allowed but they are required to pay a toll. Before this conversion, only HOV2 or more vehicles were allowed to travel the road. So we want to see what happened after this event with respect to the trips that vehicles were taking, travelers were taking, their origin, destination, and the path that they were taking to go from where they were to where they wanted to be. For this purpose, and also to try out this new data set, VDOT purchased vehicle trajectory data from INRIX. This is the same data set that is used for producing the probe data that probably some of you are familiar with and is used throughout the country. It's what is driving also the VIZ platform. And just to describe this a little bit, it consists of two types of data. The waypoint data set, which is just a collection of GPS let longs and timestamps. Those are bundled into trips, each trip being the collection of individual waypoints that it is comprised of, plus start location and start time. So 3 months worth of before and 3 months worth of after data were used for this study, 2017 March through May and 2018 March through May. The entire data set was comprised of trips and waypoints that originated, ended, or passed through the Northern Virginia region, consisted of more than 10 million trips and more than 10 billion waypoints per year. Out of those trips that used the three corridors highlighted here were filtered. So I-66 is the express corridor, which is our corridor of interest. It is in blue, shown here on the map, and is the one that is stalled during the peak times. If single occupancy vehicles would like to avoid a toll, they can actually use one of the alternate corridors, out of which 2 are main in the area and were used for the study, US 29 and US 50, or they can use what's called a mixed trip, whereby to go from one end to the corridor to another, they can start on the express lanes and switch back to the untolled lanes, or vice versa. So one thing that was known anecdotally was the tendency, the propensity of drivers to shift their trips or to try to beat the restricted travel time, and peak travel was seen right before and right after the restricted time periods. And here you can see in the top picture, the peaks for the after period in orange have shifted a little bit before, because the restricted travel time for the express lanes has been enlarged by half an hour on each side of the old HOV times. So as we expected, we see the shift in time, the shift in traffic, the peak in traffic being moved a little bit earlier, half an hour earlier in the morning, before the start of the express time, and half an hour later, also in the morning after the end of the express time. For the 66, for the peak period in the afternoon period, this is also seen for the period after the end of the express period in the afternoon, although not so much in the start around 2 or 2 o'clock. We don't see the shift. It wasn't there in the before period 2017, and it's really not that present very clearly in 2018 either. So this represents a visualization of the origins of the trips that use these 3 corridors, or either in the form of express. This is just express lanes, actually, showing at the U.S. Census tract level by the number of originating trips in each tract. So I just want to point out here that number one, the maps look similar for 2018 and 2017, not much difference shown. And also, even though these represent 4 hours a day out of 3 months, for each day out, each weekday for 3 months, the number of trips that were identified is not that high. So the most areas have between 1 and 15 trips, and the areas that are empty on the map that should kind of visually be filled in have 0 trips. So the sample size, even though it's so large, at the individual level is not very. It's quite small. In the afternoon, the same thing, only the difference between 17 and 18, not much to see. I would say that looking the difference between morning and afternoon, in the morning, the origins are spread on a much larger geographical area than origins for the PM trips, which are concentrated along the border of Virginia and Washington, D.C. in the dark blue area. Looking at origin-destination pairs, where they come and where they go, this is a map of the top 5 OD pairs for the morning express trips. So the most common trip was between the city of Fairfax and George Washington University Foggy Bottom area. And the second most common started in the triangle at Haymarket, where 29 and 66 meet, which is where really the more developed area. West of that, this is the last red area there. West of that is just only rural and rural areas, not much development. And the main destination for the trips originating there was the Ronald Reagan National Airport, which could mean that a lot of those people could have been commuters there going to the airport, or could have been travelers that were traveling through the area on the way to Reagan Airport and just turning on their GPS units over there. And again here, the number of trips recorded for these most common trips, most common OD pairs is quite low, considering that this represents 4 hours a day over a 3-month period. The same type of visualization for the afternoon period. Here, the large area over there in Washington, D.C. represents the Washington Mall, which is the origin for the second highest, the OD pair, with considering the number of trips. And the last pair here, Foggy Bottom, Fairfax City, appeared also in the morning as one of the top 5 destinations for the morning trips. So for this study, 2 types of analysis were done to try to understand the socioeconomic influences on the perceived use of the facility type that the travelers choose. Either they choose express, untold, or mixed lanes. One is by income group and the other one by distance. So here in the income group, the geographic units are U.S. Census tracts, and they're colored by the median income reported in those tracts. So the closer we are to Washington, D.C., the higher the median income is. And looking at the trips that originate in these census tracts, for the first chart over there on the left on the top, representing the trips for AM peak for I-66, show that the higher the income, the higher the median income, the lower the percentage of trips that are taken on the express lanes, up to a point around mid-range, 17 to 125, after which is kind of sort of tends to stabilize. For the looking what's happening across income groups, one thing that is evident is that trips originating in areas with the lowest median income tend to be most done on the express lanes as opposed to other types of income groups. And the mixed trips always tend to be the lowest, so which means that if someone makes a decision to take the express lanes to travel the distance either between Virginia Beltway and DC or vice versa, DC to the Beltway, they would either go on the express lanes and pay for the entire trip, or they just don't pay at all. Very few people choose to pay only for part of the trip. For the shoulder period, you'd expect a lot of the trips to be done on the express lanes, unless there's some issue with chaining, which I think will be shown in the next, will show up in the next slides. So the second analysis that was done by distance was classifying each U.S. Census tract based on the distance to the closest entry point to the express lanes. There were 3 categories. I bundled these up into 3 categories, up to 5 miles, and 5 miles represents the distance between the Beltway and Route 123, which is a very highly settled area in Northern Virginia. And the second distance, the medium distance between 5 and 20 miles, would be bounded by the intersection between US 29 and I-66 in Gainesville, after which west of this, like I mentioned before, everything else, which is shown here in light beige, would be it would be not very developed, mostly rural. So looking at what's happening by distance, generally speaking, for trips that are shorter, we can envision the fact that those short trips show a lower percentage of trips taken on express lanes as an effect of trip chaining. So these are people who generally live or start their trip within a short distance on the express lane. So even though they might need to travel the entire corridor, they might have other things on their way to where they are going, or when they're coming back, like picking up or dropping off a kid or having an appointment or doing some shopping, whereas people who come from long distances, 20 miles away, tend to stay on the express lanes. Just one explanation could be like if they are putting up with so much traffic, such a long distance, they don't want to put up with the traffic inside the Beltway, so they're just going to go and pay for the entire trip. So working with all this data, I would like to share with you a few lessons learned that I have been able to infer from all this work. This started as an experiment to try to see if we could find another way to do the work that we're doing now using user surveys and revealed preference surveys by replacing them with some form of stated preference. So the actual trip could be interpreted as a stated preference. So in this sense, it's a good comparison of the pros and the cons of each method. So for each method can actually suffer from bias and from the need to be a good representation of the general traffic. So for user surveys, this can be solved by planning and carefully thinking through the questions and the sample that the questions are being sent to. For the this type of trip and waypoint data, we don't have the luxury of choosing who our data point sources are, but we do need to validate and calibrate this data to make sure that it represents correctly. It's a representative sample of the entire traffic. So I think in this point, both of them have this issue that has to be taken into consideration, and there are different solutions to how this problem can be solved. In addition to this, user surveys usually have at the end a section on socio-demographic or socio-economic characteristics of the person who fills in the survey, which most of the time people fill in, and that is very useful in trying to understand the impact of those factors onto their travel choices. In our case, this information is completely lacking. At some point in the pipe on the source, from the source to the creation of this data set, this information was stripped down because of privacy concerns, and that is a good thing. But because of that, we have to be able to make the same analysis. We have to be able to impute and fill in and come up with this type of information from other sources, like I did with assigning each trip to a census tract and then using the median income to use as a surrogate for this type of information. And this one purchase that was made of this data came up with quite restrictive terms of use from INRIX. So it was, we're not allowed to use this for anything else other than the study of the I-66 conversion lanes from HOV to Express. And also the cost was quite high, at least compared to what our impression of that was. I would say that also if another agency or someone else would be interested in using trip and waypoint data in the form that we have used it from INRIX, they have to be warned that this is a very user-unfriendly data set. So the data came to us in a raw format that was a series, a large series of tarred and zipped, gzipped files, text files that were in no particular order. It was a very large data set, just a dump of a database, and there were really no tools to try to analyze, process, pre-process, visualize at all. So there are a lot of work went in behind the scenes that I didn't touch upon here at all to try to go from that data set to some of these visualizations that I presented here, and scripts, lots of scripts had to be custom created and written from scratch to be able to process the data. So the processing was done in R and in Python. And lastly, the nature of the data. This data is what it is, and we have to understand its quirks. So for example, there's map matching issues, and those probably are getting better over time, but still this problem is still with us, is not gone away, where segments, where different waypoints are mapped to the wrong segment, maybe it's on the wrong direction, maybe it's on the wrong roadway, and just from one particular record you cannot realize that that mapping is correct. You just kind of have to look from the context and infer whether that's right or wrong. The difference in the way providers, the GPS providers and location-based services providers ping this data and sample the data. Some of the providers get or retrieve data at 1 or 2 second intervals. Other can be 5 minutes, 6 minutes, I don't know, much longer. So all these things have to be taken into account. Plus the continuous reliance of INRIX on trucks and fleets and delivery trucks. And this means that there's lots of trajectories where you would have a trip that takes like 5 hours or so, and it just goes back and forth, back and forth, back and forth all over the place. And you just have to understand and have a deep analysis of what's going on to extract exactly the portion that is relevant to your study. So I have been using here the term express lanes, and I purposely didn't use terms like toll or fees or paying, because like I mentioned in the beginning, not all the vehicles who use the express lanes, even during the tolling periods, pay a toll. They are all required to have a transponder, but the transponder can be set into an HOV2 mode in which the trip is registered as having been made, but there's no toll involved, there's no fee involved. And this data set does not contain this information. So the trips that were on the express lanes, not all of them were paying trips for sure. And from an analysis of other data sources that I've seen recently, and I did not incorporate here, it looks like about half of the trips on the express lanes during the tolling period are not tolling trips. So maybe some of those trips that we've seen from lower income or other places will be not paying. Thank you. Yeah, so that's all I wanted to say. That's all I had. And the other future work, improve the data validation, and try to use this to model the trips and the revenue forecast on the express lanes. Thank you. Thank you.
Okay. I know many of us who live, is this on? Yes. All right. Many of us live in this area has personally experienced the 66 express lane. I think I understand what you're trying to say. Maybe I did. Is the origin of the trip shift once the 66 turn into a toll lane. Is that correct? Is that what you're trying to say?
So I was trying to see if when 66 was turned into tolling, did this change the traffic habits of the travelers we'd expect that more vehicles would be allowed, because all of a sudden the SOV, the single occupancy vehicles, would not be violators anymore. So that was seen in the percent trips that was during the common period between the old HOV and the new express lanes. And we also wanted to see if some people would try to avoid the toll and try to purposely use other ways of completing their trips during the periods when the lanes were tolled, just to avoid paying the toll. And the answer to the first question is, did we see more travel vehicles on the express lanes because the SOVs were allowed? Is yes. And did we see a tendency to avoid the tolls altogether and people just being fed up and I don't want to pay for this? The answer is no. People are paying.